Welcome back to another episode of the BMW E92. It's empty. On the right, we've got the broken S65 engine. On the left, we've got the beautiful 36,000 mile used engine. We're about to make it even better by fitting ACL race bearings. G-Tech Motorworks do keep these in stock, so if you need this doing, click the link in the bio or give us a call, send us a message on our DMs. Me and Graham, my lovely apprentice, we're going to go ahead, take the sump off, talk you through the procedure of how to do the bearings. Let's do it. Okay, so now we're going to go ahead and remove the sump. So, the sump is off, and this is in really good condition under here. In comparison to the engine that was in our E92 M3, this one's beautiful. Now, as you can see here, it turns over nice and smoothly, without any hesitation. And as I'm turning this, just a note for anyone if they're doing it at home, you want to look out for any really blue marks on the crankshaft to see where it's had oil starvation. Now this engine, I can see all the oil galleries are very full of oil. Another good one to look out for is these pickups here. Now if you look inside here and there's any big bits, there's a problem, like there was with the other one. In here you can see it's nice and, you know, there's no bits in there. Another indication, something to look out for, guys, when you are undoing these pickup tubes for the S65 M3 engine, another good indication to see whether it's had good oil in there and it's not blocked. Obviously, first I said look through these, make sure there's no big bits in there, no blockages. Now when you take these off, you should see that they'll come gushing out with oil, so they should be full of oil, like that. So there should be good flow of oil in there. And that's another indication to see that the engine has been maintained and kept up to service schedules. So that's great. And generally, this looks like a really well-maintained E92 M3 S65 engine, which I'm really happy about because the future for this is bright. So we're going to go ahead now and remove all this piping system, the pickup pipes. We're then going to remove the gasket. We're then going to go ahead and talk you guys through how the rod bearing replacement is done. Follow us. The underneath of the engine is fully exposed. We've just taken the gasket off. Now, the more I look at this engine, I can see that it's definitely not been starved of oil. It also looks like someone has been here. Although I don't have any proof of rod bearings being done to this engine, I believe someone has been in here because there's signs of like silicon, and as a mechanical engineer you can tell if some things have been apart before. So what we're going to go ahead and do, the engine is flipped over. This is cylinder number 1 and cylinder number 8. We're going to go ahead and remove the end caps just to show you. We'll remove number 1. I won't bore you with removing all of them, you can see that in a faster version, but we'll remove this. We'll show you what the bearings are like. Don't be surprised if these are uprated and someone's done them before. We're going to do them anyway because the future for this engine is big. So let's go ahead and take this big end cap off. Now you'll see a lot of people just getting the gun straight on these. We're not going to do that. We're going to crack these off. He says. Oh! Whew. I'm going to use a bigger ratchet for this. There we go. And once they're cracked off, we can then go ahead and use a power tool to whip these rod bolts out. Now when we started doing these years ago, I put a system in place there's a lot of nuts, there's a lot of bolts and a lot of end caps and a lot of bearings with these. So to keep things simplified, especially when you're doing the torque sequence, we have put in place a board which, very simple, it has the VIN number, mileage and the registration of the car, cylinder 1, 2, 3, 4, 5, 6, 7, 8. Then it has the torque sequence, because the torque sequence is massive, you'll see it. We'll definitely speed that up for you because it's boring. But you literally have to go 6 Newton meters, 20 Newton meters, then slacken it off, then 130 Newton meters, then do that 3 times basically. That's why there's 3 slots on each cylinder, so it's quite big. So all we literally do is take the end cap off before we assess the bearing, or once we've assessed it, we'll put it in slot cylinder number 1 so you don't get confused. So let's have a closer look at these bearings. Right, these are not genuine BMW bearings, so these have been done. These are some GPC Racing bearings. Okay, and they look relatively new. I think someone's done the bearings before selling the engine. Nevertheless, we are still going to go ahead and do the bearings, but this has just assured me that this engine is pretty sweet. We're going to go ahead now, carry out the rod bearings and get them in place. I'll stop a little bit later on and talk you through when we're about to do the torque process. Let's do it. So, like I said before, we're using the ACL Performance Engine bearings. That's what we recommend and that's what we use. We keep them in stock. Now, I've laid number 1, 2, 3 and 4 cylinder bearings out. They're the old bearings, they're the old bolts. I'm literally going to turn around now and go and fit these. We use the Lucas assembly lube. Now the reason we use this, guys, is any metal component that you are building, so as an engine build, this makes sure that on initial startup, there's no metal to metal contact, so they're lubricated on initial startup, which prevents premature wear, and that's the whole reason we're doing all this preventative maintenance work, so we use the right products. So we're going to go ahead now, these are the new bearings, and literally all I'll do is just apply a small amount of this Lucas lube onto the bearing, and I'll run it around with my fingers like that. You can get different kind of lubes as well. Obviously we use this. It's quite a thick paste, which is pretty good. You don't need to put a lot on. And the first one I'm going to go ahead and do is slot inside the big end bearing here. Now the big end bearings, the way these work, they've got a notch there, and so is the bearing. You slot it in like that, and you pop it straight in, and you can make sure that that notch goes into the bearing there. Excellent. Slides in just like that. Now just a quick one, while I've got the big end cap off. A lot of people have said in the comments and stuff that, how do you know they go exactly the same order? Firstly, we've produced like a board, so you don't get them wrong. Secondly, if somebody came along and got all of these and put them into one like bowl, we would know exactly which one goes when. I'll tell you why. From factory, they have a number on them, 670. So that number correlates to, which one was that? Number 1. So this correlates to number 1 piston. Now, can you see the way that they are? It looks almost cracked. That's because they are cracked. When these are produced in the factory, they're made from one block of iron, one piece. Now, when they are produced, they're literally snapped in half so that when they fit on, the fitment is absolutely perfect. There's no gap for anything. It's perfect. So that's why they are labeled. And if you have a look on this here, you come around here, you'll see that says 670. Okay? And so does this, 670. And I know that this big end cap is for that conrod. So enough of the talking, let's get walking. I'm gonna go ahead, drop these bearings in, see you on the other side. So, the new rod bearings are in with the new rod bolts. Old bearings are out, old rod bolts are out. We are now going to go through the long process of torquing it up where you're going to see it really fast. So this is part of our rod bearings board at G-Tech. So you can see the amount of times you have to do it. There's literally 3 sets. So 6 Newton meters, 20 Newton meters, 130 degrees, and then you slacken it off. 6 Newton meters, 20 Newton meters, 130 degrees, then you slacken it off. And on to the final set, 6 Newton meters, 20 Newton meters, 130 degrees, and this time you don't slacken it off because it's the final set. So I'm going to go through and show you exactly the torque procedure for the S65 M3 engine. Just stay with me. So this is cylinder 1, this is cylinder 8. And the first step is 6 Newton meters. So we've got our torque wrench here. It's set to 6 Newton meters, and we are literally going to clamp down until we reach 6 Newton meters. That's the first step. So we've done 6 Newton meters. So on to the second sequence. This time we're going to do it to 20 Newton meters using our digital torque wrench. Very precise piece of equipment this. Literally the light will go green like that when you hit your torque setting. Do it on the next bolt. There we go. And now we are going to do 130 degrees using the same torque wrench because it's got multiple settings. And here we go. So the good thing about using this digital torque wrench, it remembers the degrees that you already hit, so you don't have to keep going around. And that's 130 degrees on that one. On to the next one. So that is one cylinder, the first sequence done, the first set. We now need to slacken this off. And we can do that like this. So that is now slackened off there, ready for the second sequence. So we have finally torqued all the bolts up for the rod bolts. They are all in. The pipes are all in and tight. We've cleaned the mating surfaces for the bottom of the block. Now we're going to go ahead and do the same for the sump. As you can see, there's a little bit of residue from the old gasket sealant they've put on there. Once that's clean, we're going to put it straight back on. Get all the other ancillaries bolted up, manifolds, wiring loom, and the rest of it. And then you can join us in the next episode while we get this engine back in our M3 so it's running on all 8 cylinders. See you for the next episode.